point, CP-CPK. So CP-CPK are the measures of process capability. CP-CPK are the measures of process capability. Already we studied one measure. Do you remember that? What is that measure we already studied? It was taught by me. Anybody could recall? On day 2 morning, I taught. A measure of capability is sigma level. Am I correct?
Yes, sir.
All of you are very thorough with the sigma level, 3 sigma process, 6 sigma process.
Yes.
What is 3 sigma process?
3 sigma 95.
95 point plus something.
3.373 error points.
99.73. 99.73% success rate. A process is considered 3 sigma process if the control limit overlap with the specification limit. Am I right? The process is considered a 3 sigma process if the control limit overlap with the specification limit. There are 2 control limits, there are 2 specification limit. Am I right? There are 2 control limits, there are 2 specification limit.
Yes.
So the distance between the control limits, 2 control limit, is always equal to 6 sigma. The distance between the 2 control limit is always equal to 6 sigma. That is the denominator you had in the formula of CP. Am I right? What is the formula for CP? USL minus LSL divided by 6 sigma. Am I correct? All of you?
Yes, sir.
So what is CP? CP is specification width divided by process width. Specification width is distance between specification limit, which is simply USL minus LSL. Process width is distance between control limit, which is UCL minus LCL. UCL minus LCL is also equal to 6 sigma. If the control limit is overlapping with the specification limit, specification width will be equal to process width. Numerator will be equal to denominator. Now, what will be the value of CP? Can you tell me?
1.
That's all. When the control limit overlap with the specification limit, CP equal to 1. CP is called, potential process capability index. CP is called potential process capability index. We should use the word potential. You know why? Process is expected to shift. Do you remember we talk about shift also on day 2?
Yes.
The elephant can come to your bedroom. Why? You have locked the elephant in a small room. Same way, if you lock your process in a smaller width, the smaller width, like the control limit touching the specification limit, what will happen? Your process will also move. What we call it as process shift. If the process moves, if the process is shifting, what will happen? The capability will fall down. Do you all agree with me? If the process is shifting, capability will fall down. So CP gives the measure of capability only when the process is not shifting. When the process is shifts, CP will no more give a real picture of the capability. That is why you require CPK. That is why you require CPK. So probably to talk about it, let me get the slides so that it will be easy. So let me take the slides for you. On to the measure phase module. Here is the point. Very good. Can all of you see the, what do you call, my slides?
Yeah, it's visible.
Properly visible, right?
Yes, yes.
Okay. So this is the formula for CP. USL minus LSL by 6 sigma. You know USL, you know LSL, you know sigma. But CPK, this is the formula. In order to understand CPK, you must understand CP upper, you must understand CP lower. You should also know why we require these two things, right? For that, let me take you through. Now look at my process. The process is centered properly. Am I right? The process has not shifted. How do I say the process is centered? See here, I have the specification limit on the right, specification limit on the left. Exactly at the center, my process is also centered. And now when I apply the formula, specification width by process width, how much is the specification width? 20. All of you please stay unmuted. This is 20 and the process width is 12. So 20 by 12 is how much? 1.67. For the same situation, yes, 1.67. Now, can you see now your process is shifted? All of you are able to notice this is the original position. Now process is shifted. Now,
Yes.
now you recalculate CP. What is specification width? 20. What is process width? 12. What is CP? 1.67. Do you still believe your process is capable?
No.
No.
Earlier it was capable because control limit is seen inside specification. But now control limit is seen outside. Why? Process has shifted. But even under such situation, your CP is giving a big, good value, 1.67, which means CP has got the limitation. CP cannot understand whether the process is shifted or not. So when the process is not shifted, CP can help you understand the capability. But when the same process is shifted, CP can no more help you. All of you understand? This is the limitation. This is the limitation. To overcome the limitation, we introduce something called CPK, one more measure. What is the CPK? We divide the specification into two parts. What is the specification width earlier? USL minus LSL. And this is the center. Now specification width is divided into two parts. What will be this length? USL minus center is X bar. Can you understand USL minus X bar?
Yes.
Similarly, width of the green bar is X bar minus LSL. Similarly, process width also we divide into two parts. How much is the process width? 6 sigma. When you divide into two parts, 3 sigma here, 3 sigma here. All of you understand? We now divided the specification width into two parts, process width into two parts. Now find out a ratio. The blue bar divided by 3 sigma, green bar divided by 3 sigma. Blue bar divided by 3 sigma is called CP upper. Green bar divided by 3 sigma is called CP lower. If the process doesn't undergo the shift, blue bar by 3 sigma will equal green bar by 3 sigma. All of you agree with me?
Yes, sir.
But if the process is shifting, they become unequal. So we have two values now, CP upper, CP lower. If CP upper is equal to CP lower, there is no shifting. But if CP upper and CP lower are different, you can understand your process is shifted. Imagine your process is shifted to the right side. Now tell me, which one will get affected now? The blue bar or the green bar? Which one is reducing now? Blue bar or the green bar?
Blue bar.
Blue bar is reducing. So blue bar now captures your risk. Blue bar is able to capture your risk. So the blue bar divided by 3 sigma is known as CP upper. Green bar divided by 3 sigma is known as CP lower. Which one is now measuring your risk? Helping you to measure the risk? CP upper. Whichever is lower, that will carry the risk. So our formula for CPK is minimum of CP upper and CP lower. Which is carrying the value? Cp upper. Look at the Cp upper. How much it is Cp upper? 0.8.
0.8.
But Cp lower 2.5. Out of the two, now you should pick up 0.83 only. Now Cpk is 0.833. But for the same process, Cp is 1.67. Sorry, under this condition, if you calculate Cp, this will be 1.67. But Cpk is 0.833. Now, which one is giving you a real capability? Cp is giving a real capability or Cpk is giving a real capability?
CPK.
That's all. So this is the difference between Cp and Cpk. If you want to understand the real capability, look at the Cpk, not the Cp. Look at the Cpk, not the Cp. We are teaching you both simply because industries use both of them. There is a purpose. There are certain inference you can draw from Cpk. There are certain inference you can draw from Cp. Now you know the purpose of Cpk. If Cpk is more than 1.67, your process is capable. Look here. Cpk is more than 1.67 or 1.66. You can understand your process is capable. Sorry, here I think what is written? Process is not only consistent, process is capable. You must say capable. Process is consistent also, capable also. Process consistent as well as capable. Because Cpk is more than 1.66. You don't have to look at Cp. You don't have to look at Cp. Please note all of you, always your Cp will be greater than Cpk. That's how the formula is designed. If Cpk is 1.67, Cp will definitely be more than that. What is the required value? Hope RK could have told you. What is the required value for Cpk? Industry standard 1.67.
68.
66 or 67. For critical process, 1.66 or 67.
1.6.
For non-critical process, 1.33. Pass mark is 60, but you will be targeting 90. Am I right? Pass mark is 60, but you are preparing for 90. Something goes wrong. Question is tough. Then also you will conveniently score 70 or 80 marks. You will pass the exam. That is why we have a higher slab. That is why we keep Cpk as 1.67. Suppose if the process is not critical, 1.33 is also okay. Suppose if it is a model exam, I give a Google form today. You can make a try, isn't it? So less critical means 1.33 is good. More critical process means 1.67 is required. Now, always you need to check Cp and Cpk. Compare Cp and Cpk. If both are equal, what you can understand is your process has not undergone any shift. Do you agree with me? All of you understand this? Only when the process is shifting, Cpk will differ from Cp. Otherwise, it will be equal. So first you check whether Cp equal to Cpk or not. If it is equal, please understand your process has not shifted. Now look at the value of Cpk. If Cpk is more than 1.67, make a conclusion your process is capable. If it is less than 1.67, your process is not capable because always assumption is process is critical. Now, when the process is not capable, what are we supposed to do? What are we supposed to do? There are two things. Either you have to move the mean, close to the target, or you have to reduce the variation. How to do that? Let us see that with some example. See here, there is a problem here. The details are here, theory is here. Upper spec is available, lower spec is available, process average available, process standard deviation available. With all these things, you can calculate Cp because you now know the formula. Am I correct, all of you?
Yes, sir.
RK has given a template. If you put it, that will give the result. But now manually you calculate. Cp is found to be 0.8. Now you go for Cpk. Cpk formula is minimum of Cp upper and Cp lower. Cp upper, you know, USL minus X bar by 3 sigma. Cp lower, you know, X bar minus LSL by 3 sigma. Now you have two value. You know, Cp upper is 0.4, CP lower is 1.23. Tell me which one you will choose, minimum one or the maximum one?
Minimum one.
Out of the two, whichever
0.4.
0.4, not the maximum, minimum. So CPK
Minimum
is
only we have to.
minimum only you should take. CPK is 0.4. Now it tells us CPK is 0.4, CP is 0.8. Do you think the process has undergone a shift?
Yes.
Yes. So you must move the process. That is why the suggestion comes like this. As a statistician, you are advising the company to move the process mean towards target value or towards center. Process is not at the center. Process is shifted. Particularly, the process is shifted to the right side. How do I say? CP upper is smaller value, isn't it? Process is shifted to the right. Move the process to the left. Move the process mean to the target. And look at your CP value. CP is a measure of variation. CP is a measure of variation. How much is CP? 0.8. 0.8 is too less, which means variation is too large, which means your process is wider. In addition to the center, not at the target, your process is also wider. So you must go for reducing the variation. Two things you need to do to enhance the capability. One is move the process to the target or move the process mean to the target. Another thing is reduce variation. All of you understand?
Yes, sir.
Any doubt? Any doubt?
This CP
No, sir.
formula is specification width process width divided by process width.
That's all. Process width is 6 sigma. Specification width is USL minus LSL.
Okay.
Similarly,
So
for
if it is,
CPK, you
if
have two
LSL
things.
is in 10, if LSL is in 10, then the specification width would be 20 and process width would be 6 sigma. So 6 into sigma value, whichever we are given. That is the
Whichever is
calculation.
given. If it is given in the problem, use it. If it is not given, we must calculate using the data.
Exactly, sir. I have a doubt. Like, in which industry exactly this formula is works up? Like,
See, we can use it wherever required, we can use it because I already told you sigma level, CPCPK and DPMO and the rejection rate. These are all connected.
it's all interconnected according to the industry.
When CPK equal to 2, it is equal to a sigma level of 6. That's all. When CPK becomes 2, your process is doubly capable. When CPK equal to 1, your process is just capable. You remember I explained it, just capable, doubly capable. Just capable means CPCPK equal to 1. Doubly capable means CPCPK equal to 2. So you can convert the CPK into sigma level simply by multiplying 3. Now 1 point, let us say how much it is, CPK equal to 0.4. Multiply by 3. What will be the number you will get?
Around 1.3.
1.3 is the sigma level. 1.3 means 70-75% success rate. 25 to 30% rejection will happen. That is why we call the process as not capable. So you need to actually, it takes time for you to digest everything, but it's all same. Probably if you come across some examples, you will be able to better understand. See here, one more case. Now all of you can try. An electronic process, manufacturing process. Current flow specification is 100 plus or minus 10. Now tell me USL, LSL. Do you know the USL, LSL here?
Yeah, 110 is USL and 90 will be the LSL.
Very good. Process mean and estimated standard deviation. What is process mean here? What is the symbol? X bar. X bar, isn't it? You see X bar is coming in your formula. What is X bar? Process mean. Standard deviation 1.5. Now compute CPCPK. Substitute in your formula. CP equal to 2.22. CPK, you have two value. Tell me which one will you choose?
0.66.
Very good. So CPK is 0.66, CP equal to 2.22. It means variation wise your process is okay. Variation wise your process is okay. But your process has undergone a shift. Now the remedy is only move the process mean towards the target. Variation is not a problem. Why do I say variation is not a problem? CP is more than 2, isn't it? Problem happens only because of two numbers. One is average, another one is standard deviation. Standard deviation is not a problem, but average is a problem. Since average is a problem, you are advising the company to move the process closer to the target. All of you understand?
Yes, sir.
So here I can take that sigma level 1.5 or differential, whatever we are fixing that is a standard process limit what we are othering as per SOP.
Yes.
So the calculation wherever we are interpreting, we can fix this as a standard deviation limit based on which we can derive the numbers.
Exactly.
Okay.
So similarly, so any number of example you can now work out. And see here, this is the extrusion process. Extrusion is a kind of manufacturing process where you force the metal to go through a die and then, the other side, the product comes out. The diameter is a critical to quality characteristics. The specification is this one. USL, LSL. Process average is given. Standard deviation is given. You are calculating CP equal to 1.11. Now tell me, are you happy with the value 1.11?
Borderline.
You are not happy. So not happy means what is the problem now? Looking at the CP, variation is the problem. Process is wider. So now you give an advice. As an expert, you give advice. Reduce variation. That is the advice. Now CPK. There are two values, 0.66, 1.55. You always choose the lower one. So CPK is 0.66. Now tell me, is this CPK equal to CP?
No.
So what is your advice?
Need to move mean also.
That's all. There are only two remedy for all the problem. Move the mean, reduce the variation. This is how doctors are also treating you. If you are going to a doctor for a health problem, let us say, a patient goes to a doctor for a diabetic condition. Why the patient is called a diabetic? The 3-month sugar average has increased, isn't it? Yes or no? The average is shifted.
Yes.
So now you are calling him as diabetic. So the doctor will try to move the average to the normal. That is the remedy. Am I right or not? For that, he might give medicine. He might give a lot of things. But now, before giving the remedy, the doctor must ensure your body is stable. Stable means sugar will stay in that level only. Then only I will declare you are a diabetic. Otherwise, I cannot declare, isn't it? Your sugar level is high as well as low. Average is automatically normal. So, in order to treat any patient, first thing as an expert, the doctor will be doing is he will help you to stabilize your sugar level, your eating pattern. He will try to make it uniform. Do you understand or not? You can see the doctors, guiding the patient in this manner. Morning, you eat this much. Afternoon, this time, this much. They will try to control the calories. Am I right?
Yes, sir.
Controlling the
they will
calories
take-
means
Even they
controlling
will
the
take
calories.
multiple tests also to understand the variation.
Controlling the calories means controlling the variation. Controlling the variation means, every single day I consume same amount of calories. So doctor can now make a solid conclusion. Since this person is always, the daily lifestyle is same. Now why the sugar level is staying at a higher level? Now what can be done to bring the sugar level down? So always a remedy to a problem. There are two things. One is variation should be under control. Another thing is the
Mean.
process average mean should be moved to the targeted value. That is why we are also saying here, move the mean closer to the target and reduce the variation. My targeted sugar level is less than 100. My average, 3 months average should be less than 5.5 to declare me as non-diabetic. That's all. That will happen. That will definitely happen. If you have a proper daily routine, every day, your lifestyle is same. You are now controlling variation. If your lifestyle is same, you are controlling variation. Now I make positive changes in my lifestyle. Now you know what will happen? My process mean will move. Do you understand? When I maintain the same lifestyle, my variation is very less. Now I make some good changes in my lifestyle. I bring exercise. I started eating vegetables, taking fresh fruits and juices. Now my habits have improved. This will help me to bring down the sugar level. Now I can be declared non-diabetic. If I do this consistently over a period, definitely sugar level will get reversed. The same thing is applicable to manufacturing industry, logistics industry. In healthcare, HB1AC is the metric we are trying to optimize. In your business, there could be similar metric, isn't it? It could be diameter, it could be length, it could be surface finish, it could be anything. All of you agree with me now? Understand? Cpk?
Yes, sir.
For a process, Cp equal to 0.94, Cpk equal to 0.33, which means the process is not capable. Tell me, what will be your advice?
We need to move both variation and mean.
Move the mean, reduce the variation.
Move the mean, reduce the variation.
Move the mean, reduce the variation. That's all. Now you understood Cpk.
But that isn't like a generic statement like move the.
Yeah, move the mean is the general statement because we only talk with the numbers in general. If we go to a specific case, then only we will be able to talk using specific statement. Now I only raised Cpk. That's all. I didn't explain the context. So it's a generic statement only you can make.
Would be there any situation that to increase the variation to maintain the mean?
No.
Why so?
Variation is an enemy. We like variation only while tasting the food.
Okay.
We need variation. A bowler, you are a batsman. A bowler is bowling. He is keep on varying the ball. It will be a trouble for you, isn't it? So variation is the problem for us also in the business. The diameter keeps on changing. It is irritating me. I need only 10 mm.
I got it. Then the generic advice would be reduce the problem.
Reducing the variation means you are expecting consistency. But you can be consistently good. You can be consistently bad also. But first requirement is consistency. If consistency achieved, then you can try to convert the bad into good. How will you do it? By shifting the average towards the required value. When I shift the average towards the required value, all the bad items will now start becoming good items. When there is too much of variation, both the bad and good are happening. If both the bad and good are happening simultaneously, it is difficult for you to manage the situation. That is why you are first controlling variation to understand whether the situation is really good or bad. If it is bad, how much bad? You get an idea. First, you control the variation. Then look at your average. If the average is not at the right place, push it to the right place. Your problem is solved. This is a generic idea, generic advice, which will work in all industries. That is why you must understand standard normal distribution. I told you other day. Standard normal distribution. So, or at first normal distribution, then standard normal distribution. Because ultimately we understand the problem through average, through standard deviation. Through average, through standard deviation. We expect normality everywhere. We expect normality. If there is abnormality, we don't like, isn't it? We expect normality. If there is an abnormality, we try to control it. So how do we know whether things are normal or abnormal? Through the average and the standard deviation. All right, Cpk, I think one of your doubt is clarified. Am I right?
Yes, sir.
So now you also spend some more time on the same content. And now you can go back and watch the same recording. Now you will be able to appreciate. And try to play with his templates. He has given a template, isn't it? I believe. Yes or no?
Yes, sir.
You put different values of USL, LSL, different values of average, standard deviation, and see what happens. And that's how you can gain a deeper understanding. Now, what is the other question our Bhavin was saying? Bhavin, you are asking something, right? What did you ask? Bhavin?
Lean.
Lean. Okay. See, lean is, a mindset and a culture. If you lean is like, I will say, lean is like improving the efficiency. Lean is like improving the efficiency. What is Six Sigma then? Improving your accuracy.
Okay.
Whether your item is good or bad, Six Sigma is checking. The item is bad, you control the variation. You control the process center so that the bad can become good. Now all the items have become good. You are selling it to the customer. Customer is very happy. You know why? All your items are good. Customer is very, very happy. But even after started producing quality products, your business is not impressive to the owners. You know why? Why? Tell me.
Not making much profits.
Profitable.
That's what. Why?
Maybe there is more consumption of resources,
What
lengthy
you produce,
process.
exactly. What you produce is really good, but how you produce is really very, very bad. What you produced is good, but how you produced it's bad. Do you understand the difference between what and how?
Yes.
How is the way you produced it? I can prepare a good coffee with less effort also. I can prepare the same good coffee putting more effort also. If I put more effort, probably I will end up, not making any profit. But you will still enjoy my coffee. Anyway, you are going to pay me 10 rupees for the coffee. Since I am putting more effort, will you pay me 100 rupees for the same coffee? So customer has a fixed price in mind. So it is also important for you to think about the efficiency. Efficiency is how you produce. Are you over consuming the resource? Are you over consuming the resource? Now tell me, what is a resource? One of you. What is a resource?
Resource can be employees, the resource can be the material, resource can be
It can be a
the
4M. Main material, machine, method.
Time? Do you think time is a resource?
yes.
Yes.
Material is
Time and
resource.
Material.
Do
Men.
you think effort is also a resource?
Yes.
Yes.
You put more effort, that is going to cost more, isn't it?
Yes.
Yes,
You
sir.
put, so all these things you should try to minimize. If a work can be done in two ways, adopt the one which requires less effort. But in any case, there is no compromise on the quality. No compromise on, without compromising the quality. If you minimize the resource consumption, your approach is called lean. That's all. Approach is called lean. If you do the work repeatedly, you are inefficient. Cpk session is conducted twice. We are inefficient now. We are effective. Finally, we made it. But still, we are inefficient. We should know that. Then only improvement can happen. What can be done so that people can understand the concept in the first attempt itself? Isn't it? You have to think deeper to the extent that you prevent people from thinking in an unnecessary manner. Anything you do, anything you consume in excess, that is inefficient. Not only material, not only effort, not only money and time. If people are let us say they are thinking irrelevant matters when they are on the job, that is also a waste. I mean, can I say like that? You are paying salary for the people to be on the job, but your employees are thinking about the movie that is getting released this Sunday. Do you still consider this kind of work as a productive activity? No, it is unproductive. They should be focused on the job. So can you think of going to the extent of creating an environment where people will be always focused on the job? That is why you require 5S. Workplace is neat, clean, well organized. People will be motivated to work. That is why, people are going to office, sitting and working. Do you understand? So lean is improving your efficiency. How we improve our efficiency? By reducing the resource consumption, by minimizing the effort, by minimizing the time. In order to minimize the effort, minimize the time, you should know what particular step is value adding, what particular step is non-value adding. If the step is value adding, it is productive. If the step is non-value adding, it is unproductive. Unproductive means waste. Unproductive means waste. In Japanese language, it is called as muda. In Japanese language, it is called as muda. Do you understand? If you do a lot of muda, do you think the customer will happily pay?
No, sir.
Nobody is going to pay. So you need to know whether what you are doing is a muda or a productive work. If it is productive work, customer is willing to pay. If you do something unproductive, still expect the customer to bear the expense. No customer will be with you for in a long term. Since you are charging them, they may be with you for some time, but definitely they will start look for alternative and then they will move out. So if you really wanted to avoid, you need to know what is productive, what is non-productive. The productive activities are called value adding. The non-productive activities are called non-value adding, also called as waste. Now, do you all understand what is lean?
Yes, sir.
Trust me, most of the business processes are unlean, which means only 20% of the activities are productive. 80% of the activities are unproductive, which means 80% of the activities are non-value adding, which means 80% of the activities are wasteful activities. You can easily correlate it with anything you are doing, or everyone is doing. Consider our own training program. How many hours we conducted the training program on Saturday?
Up to 6:30.
How many hours? We started by 9:30.
Up to 6:30.
It went up to
6:30.
5:30.
5.
5:30.
6:30.
6:30. Yeah. Oh, really? Why it went up to 6:30? Okay. Schedule is up to 5 o'clock. Okay.
Sunday it was closed around 5 o'clock.
Saturday?
Saturday is the first session, no? So it went, I think, long.
5:30 like.
Okay. Let us say, 8 hours.
Sorry,
8 hours is the training time. Okay. In that, 1 hour we allotted for lunch. Am I right?
Yes, sir.
Have we done any useful work in the lunch time, in the 1 hour lunch time?
Had a food, no, that is very much useful.
No, I agree. That is definitely essential. That is why we allotted 1 hour for the lunch. That is essential. We cannot skip. But anything happened to your knowledge level during that lunchtime? Have you learned anything? You have joined us for the learning. Learning is the goal. As far as the learning is considered, nothing happened during the lunchtime. So from the lean's perspective, that 1 hour is a mood off. Do please understand that and work on it. But we cannot avoid lunch. But can we reduce the lunch break?
Yes.
Can we make it to 45 minutes? We get extra 15 minutes. This is how you improve your efficiency.
Correct.
Wherever elimination is possible, eliminate. Wherever elimination is not possible, reduce. This thinking is called lean. If people don't know this, they will spend all the time in the wasteful activities and then end up creating lot of inefficiencies. You understand? Similarly, morning tea break. How many time? How much time?
15 minutes.
15 minutes. Evening tea break, 15 minutes. And the very first day, up to 11 o'clock, we were only doing the introduction, trying to understand each other. There are many things we have done, but we have not opened the discussion. First 1.5 hours also gone. Nothing to do with the green belt body of knowledge, nothing to do with the black belt body of knowledge. Imagine how much time we lost. 1.5 hour introduction, 1 hour lunch, half an hour tea break. Totally how much time? 3 hours out of 8 hours has gone just like that. Without doing any productive work. You have been charged for it, isn't it? You are all charged for being present in the program, but then 3 hours, knowingly, unknowingly, spent on unproductive work. Similarly, many things. Every time, when we start, we are asking, is there a screen is visible? Am I audible? Every time screen is visible only. It should be visible, but still we are checking. We are doing, rework. So we need to think on everything. Then only, your performance will improve. So this thinking is called lean. Once you understand all these concepts to the core, everything will start appearing as a problem to your eyes. People will start running away from you. Because in everything you will be able to find an improvement opportunity. Improvement opportunity means in some problem has become visible to you. If they are doing in this manner, then you will tell them, hey, don't do like this. This is taking more time. Can you change it? You instead of doing in the left hand, do it in right hand. You will do it better. You put the workpiece on the left side, not on the right side. Increase your chair height, increase your table height, your productivity will improve. All these suggestions will come because now you are able to think in a matured manner, isn't it? So basically work study and time study we need to do so that unproductive activities can be identified, eliminated. But till you understand the concept of lean and the principles of lean, you may not be able to conduct the work study and time study. Do you understand what I'm telling?
Yes, sir.
You should always look at the work, at the micro level. Micro level. A worker is loading the workpiece in a machine tool. Before loading the workpiece, he is picking up the workpiece. Am I right? After picking up the workpiece, he moves by, 30 centimeter. After moving 30 centimeter, he is loading it in the machine. Now, how many activities are there? Pick the component, move the component, load the component. Earlier, it was just, loading the component. That's all. Now, there are 3 items. Pick, move, load. Now, the movement is 30 centimeter. You are bringing an improvement there. You are reducing it to 15 centimeter. Half the time is reduced. Because picking the item, moving the item, loading the item is a non-value adding activity. Am I correct or not? Only the machine starts, it is productive. But for picking and moving and loading, if they are doing the work in a complicated manner, obviously your resources will be overconsumed. So you need to think in this manner to improve the efficiency slowly, slowly, slowly. It won't happen in overnight. There will be several cycles of improvement. Hundreds and thousands of improvements will happen. These small improvements are called cases. These small continuous improvements are called cases. Several thousand cases will improve your efficiency, will improve your profit. People will start feeling more comfortable after implementation of all these improvements. Am I correct or not?
Yes, sir.
So initially people might think, we are studying them, we are controlling them. They might think, we are actually, doing a lot of micromanagement, but actually for their welfare only. After all the improvement, they will feel more comfortable. Simplification. Finally, the meaning for lean is simplification. Simplify everything. Clear? So second doubt also clear. Cpk and then lean. So ultimately, to know whether what you are doing is value adding or non-value adding. What you are doing is productive or non-productive. You just have to ask 3 questions. First question, will the customer pay for what I am doing? Just ask yourself, I am doing the work. Will the customer pay for it? If the customer says, okay, man, I will definitely pay for it because what you are doing, I find value in it. If the customer says, then your work is productive. If the customer is not willing to pay, then what you are doing is non-productive. Let us say you keep a lot of inventories in your company, in your workplace. Do you think the customer is ready to pay for your inventory? I keep a lot of stock. Several crores are required to keep the raw material. But according to customer viewpoint, it is non-value adding. Whether you keep inventory for crores or you keep inventory for lakhs or you keep inventory for few thousand rupees, it is immaterial for the customer. That is the reason why inventory should be minimum. Because inventory is a waste. Till certain point of time, you might think that inventory will help us when the material is not available. How come we produce? We need inventory. But the moment we realize inventory is a waste, we will try to optimize even the inventory. Rather, you strengthen your relationship with the supplier. Instead of managing the situation by keeping inventory, can you think of managing the situation by having a good relationship with the supplier? Am I right? Every time an item is needed, it is just an email away. I send an email, within 4 hours, item is delivered in my workplace. Now I don't have to keep a huge inventory. Do you understand the difference now? But creating a good network of suppliers requires proper supplier management. You will have a purchase manager, somebody will be working on it. You will have reliable suppliers. Only then you will be able to minimize the inventory. Otherwise, what happens? Your production will get affected because raw material won't arrive on time. Why? Poor network of suppliers. So till you are able to, bring a good network of suppliers, you have to live with the inventory. Once you are able to connect with good network of suppliers, you can even think of zero inventory. Am I right? Like for example, Amazon. There are many items Amazon doesn't hold any inventory, but you can still purchase from them. Am I correct or not? Many items Amazon doesn't have even a single piece. They have not invested. Why? They have such a good network of suppliers. They even find them if they don't deliver. Am I correct or not? Inventory is one of the 7 waste. You should be able to manage all the 7 waste. What are the other waste? Inventory, transportation, motion, or production, or processing, isn't it? Then defects. Waiting. Waiting is another thing, defects. So you need to understand all those things. And I think lean is not difficult to understand, but then it is a mindset, because generally people don't accept, something as waste. You know why? Because I have been doing it, so long. How can you suddenly come and say what I'm doing is waste? I won't accept. This will be the mindset of the people. So you need to teach them first the basics, make them understand the definition of waste, and then they will come forward and cooperate with you. Yes, what you are telling is correct. Now it is saving my time. Now it is reducing my effort. Now it is reducing the resource consumption. So when I reduce the resource consumption, obviously my profit will improve. So once people know all these things, they will start cooperating. And that's how improvement happens. All right.
Sir,
Yes.
this gauge RR, can you just throw light on it? Gauge
No,
RR.
that was
for-
not yet taught, no. So don't worry about it right now. I'll be teaching it coming Saturday morning.
Okay.
It
Then
was
other
not
one,
taught.
no, it was okay. It was just touched, I think, by his name. I don't know. Then other one is FPY, RPY that roll through.
Those are easy concepts you should have understood. FTY, RTY. And there is one more Y, traditional Y, isn't it?
Traditional Y and FPY, RPY.
Traditional Y is how many pass, how many fail. That's all. FTY is how many first pass. There is a difference between passing and first passing, isn't it? When your child is studying, will you like your child, failing in an exam, clearing the exam by writing arrears? We want our child to pass in the first attempt. Similarly, when you produce product, you should produce right products in the first run itself. In the first run itself. If the first run is not successful, what do? You will do a rework. Am I correct? If the first run is not successful, you will do a rework. For example, Cpk, we have done a rework now. First run was not that much successful, so we have done a second run, another half an hour spent on Cpk. Now tell me, rework, is it good or bad for your company?
Bad.
Bad only. It's a waste.
Yes, this understanding will allow you to believe on the first pass yield, not the traditional yield. If you think rework is good, you will calculate and you will be happy with the traditional yield. Somehow my student passed here, but have they passed in the first attempt? That is my question. 100 students wrote the exam, all 100 have passed. But when I look at the data, now I understand half of them wrote the exam 2 times. Which means there were something wrong in the first run. Either they have not attended class or they were not monitored properly. That's how. So traditional yield is simply output by input. But first pass yield is output minus rework divided by input. All the rework you must subtract from the output. Then only you should calculate your yield. Those of you so far you are calculating yield simply using the formula output by input. Your formula requires modification. Output minus the rework. Don't accept rework as a good work. If your team members, they say, sir, I have completed this much. Yes, you have completed, you have done 80 tasks, or you have done, 80 cycles successful. But out of the 80, 20 cycles, there was a rework involved. So I don't accept that as a completion. If you produce 100 units, your people might say, sir, I produced 100 out of 100. My success rate is 100%. Now you ask, out of the 100 items, how many items undergone rework? Sir, 40 items undergone rework. That means your success is only 60%. Earlier, their claim is 100%. But out of the 100, 40 units undergone rework. So first pass yield says 60%. Traditional yield says 100%. All of you understand the difference now? Then what is throughput yield? Throughput yield is output from a process becomes input for the next process. Output from a process becomes input for the next process. Let us imagine a scenario like this. People are joining your green belt program. Whomsoever qualify, they join your black belt program. Whomsoever qualify, they join your master black belt program. This is the sequence now. Now, how many trainings are there now? 3 training: green belt, black belt, master black belt. Imagine 100 people have joined your green belt program. Out of the 100, 90%, 90 students qualify in the green belt exam. Now, how many are eligible for your black belt?
90.
90. Now, 90 students sit in your black belt class. 80% of them qualify in the black belt exam. Now, how many have qualified now? 80% of 90. What is 80% of 90?
74.
72.
72.
72.
Correct.
72 students have now qualified. 72 students have qualified. 18 students have failed. Am I right?
Yes.
Now, how many will sit in your master black belt program?
72.
72. Now, 70% of the students are able to clear your master black belt exam. Now, what is 70% of 72?
72, 71, 21. Close to 50.
Close to 50. So 50 students have now become an successful MBBs, master black belt. Now, how are you performing? Are you happy with your performance? 90% in the green belt, 80% in the black belt, 70% in the master black belt. Do you think you will be happy? Are you happy with the performance now?
Performance is only 60%.
Performance is?
Only 60%. Out of 90, only 50s are eligible for the final.
Out or not out of 90? Initially, how many joined your institution?
90.
No, 100 joined.
100.
People trusted your institution, but finally 50 of them successful.
So 50-50 ratio.
Now you will be able to realize the opportunity for improvement. If you look at the 90, 80, 70 separately, you don't fully understand the improvement opportunity. But when you calculate the overall, you understand you are only 50%. Your effectiveness is only 50%. Half of them are failing. Because ultimately the overall output is important. In any business, the final product is saleable, isn't it? Not the intermediate product. If the intermediate products you can sell, then it's a different story. Always intermediate products we don't sell. We sell only final product. So the failures at the intermediate stages are also failures. You need to account them. So in order to get the 50%, the formula is 90% into 80% into 70%. Or otherwise 70% of 80, 90% into 80% into 70%. 0.9 into 0.8 into 0.7. That will come to 0.5. The 0.5 is called throughput yield. You understand?
Yes.
Always in business, there will be stages or there will be multiple processes. Every process will have a yield. Multiply all the yield. That will be called throughput yield. When you want the throughput yield of 100%, all the yield should be 100%. Am I correct or not? If one of the process yield is 0, the overall yield will be 0. If one of the yield is 0, the throughput yield will be 0. So which is a better metric we can rely on? Throughput yield or the traditional yield? Throughput yield. Why we now switch to throughput yield than the first pass yield? Because processes are connected. The output becomes input for the next. Whenever an output of a process becomes an input to the next process, you must look at the throughput yield, which is product of all the yield. Is that clear now, all of you? So some thinking, that's it. So it's again a common sense only, but then it is coming as a formula. So rework is excluded in the traditional yield. Rework is included in the first pass yield. And the throughput yield is calculated by multiplying the first pass yield of all the stages of a process. That's it. Clear now? All right.
Yeah.
So we have discussed three items today. One is Cpk. Another one is the basic concept of lean. Another one is different types of yield. The traditional yield, the first pass yield, and the throughput yield. I hope you gained a proper clarity on all the things, right? Probably now you can revisit the recordings. You will definitely be able to appreciate. The thing is, the first run sometimes, will be difficult to grab the points. So now you revisit, you will definitely understand. And what I will do is I will immediately, now I will post a link in the group, WhatsApp group, which will allow you to go through various questions in the defined phase. So where do you stand as of now? That is going to be your baseline. Where do you stand as of now with respect to the defined phase? Please do take up the exam and see for yourself where are you with respect to the expectation. If there is a lagging, go through the material and then try to correct yourself. And similarly, next week I will share questions for measure, analyze, improve, and control also. Please understand, lot of effort is required from your side also to get the feel of the transformation. Am I right? Out of the 15 people who joined the program, only 3 are here, 20% is here. 80-20 rule is working, Pareto. So some effort is required from your side also to benefit fully from the program. So understand that responsibility, and whenever you get time during the course of the training, please do spend some quality time. Similarly, tomorrow also there will be a class, RK will be teaching, and try to learn from that class also. Same way it will repeat every week. All right?
Sir,
Okay.
videos, I think they were not posted, it seems. I thought of going through once again the videos in the app.